Hello, I'm Miles Tails Prower. We will learn about banking of curves. Banking of curves is a turn or change of direction in which the vehicle banks or inclines, usually towards the inside of the turn. For a road or railroad, this is usually due to the roadbed having a transverse downslope towards the inside of the curve. Assuming that the surface is frictionless, any object which is banked on a circular track moving with constant speed v. If you are looking on either side of the curve, we see a cross-section right-angled triangle. The resultant or net force on the object found by vector addition of the normal force exerted by the road and vertical force due to gravity must equal the required force for centripetal acceleration dictated by the need to travel a circular path. You could ever imagine in the Green Hill Zone, Sonic runs faster in the banking of curves. If the bank angle is 0, the surface is flat and the normal force is vertically upward. The only force keeping the vehicle turning on its path is friction, or traction. To talk about the radius of a curve on a road, if a radius of a curve is too small enough and a car has to make a very sharp turn, it will skid off in case of high speeds. To not let the car skid off, the radius of road curvature must be increased. This must be large enough to provide the centripetal force, a relationship which can be expressed as an inequality. Assuming the car is driving in a circle of radius r, the expression is given by mu times mg, greater than m times square velocity over radius r, where mu represents the coefficient of friction. The left-hand side of the expression is the maximum frictional force, which equals the coefficient of friction mu multiplied by the normal force. Rearranging to get the value of velocity. The velocity v is less than square root of radius times mu times g. You may note that mu can be the coefficient for static or dynamic friction. According to the Newton's second law, we can now set the horizontal component of the normal force equal to mass multiplied by centripetal acceleration. We have two equations, n sine theta equals mass times squared velocity over radius r, and n cosine theta equals mg. When you solve, let's substitute n sine theta equals mg tan theta. Then to find out the velocity, we now get v equals square root rg tan theta. The magnitude of this velocity is also known as the rated speed depending on its frictionless surfaces. So you now know how the banking of curves work. Like, comment, and subscribe now on YouTube.